this video, we're going to talk about implicit differentiation. So implicit differentiation is really just a special type of the chain rule where we look at y as having an inside, as y being an inside function of x. So remember, y is a function of x. So whenever we take a derivative of a piece that has a y, we have to tack on a dy dx. So let's start by looking at the natural log of x times y. Let's just start there. Now when we look at that, we notice we have an outside function, which is natural log, and an inside function, which is xy. So let's do our chain rule. Our inside function is x times y. So our outside function's derivative, is going to be 1 over x. And in order to take the derivative of the inside function, we have a product of two functions. So we have to use a product rule. So we start by taking the derivative of x, which we know is 1. And then we multiply that by y. So we get y. And then we add x times the derivative of y. Now, if we were taking the derivative with respect to y, our derivative would just be 1. But we're taking the derivative with respect to x, which we know because we see this dx right here. So that means I have to do dy dx instead of just 1. Now let's put our chain rule together here. So the derivative of the natural log of xy is our outside evaluated at our inside, which is xy, times our inside derivative, y plus x dy dx. Right? So now let's look at the full derivative. So we want to take d dx of ln of xy plus 2y, and then the derivative of x cubed. Right. Well, this is really just a derivative, a sum of derivatives over here. So we would take the derivative of natural log x plus y plus the derivative of 2y. We've already done natural log of x times y. So we've got 1 over xy times x, times y, plus x dy dx. And the derivative of 2y, well, it would be just 2, but since we're taking the derivative with respect to x, we have dy dx. And on the right side, we have our usual power rule of just 3x squared. Now I have to get all my dy dx's to one side and everything else to the other. So I'm going to distribute my 1 over xy into my parentheses. And when I do that, I'm going to have just a 1 over x, 1 over x, and then I will have a 1 over y dy dx. Now, 1 over x has no dy dx's in it, so I'm going to subtract that to the other side. And now you see I have a dy dx in common on the left side, so I factor that to the front. And now I just have to divide both sides by 1 over y plus 2. So dy dx is 3x squared minus 1 over x, all divided by 1 over y plus 2. Now that's a perfectly fine answer. But if I wanted to make this look better, so I only have one numerator and one denominator, I can multiply everything by x, not y, x times y. And I'll get this nice clean version that looks like this. Let's see, so we have 3x cubed y minus y over, let's see, we would have x plus 2xy. So that's the nice clean version of your answer. But again, the previous line would be okay for your final exam.